Today I'll be showing you how to balance equations properly because I know it can be a tricky topic. So we're going to go over a few equations and try to balance them. Okay, so the first equation, we have oxygen reacting with some ammonia to produce this compound HNO3 and some water. So the first thing that you want to do is you want to first count the atoms on both sides, okay? You can't just like guess it. You could maybe get it right, but you want to count the amount of atoms on both sides, so then you can see what is imbalance. So what I'm going to do is I'm going to set up a table like this. So O, N, and H. So you have O, N, H atoms on both sides. O, N, H, O, N, H. Okay. And then I'm just going to draw like a table like this. On this side, we have two oxygen atoms. This side, we have one nitrogen. And this side, we have three hydrogens. Okay. Then this side, we have four oxygens, three and one. Then we have three hydrogens, two and one, and then one nitrogen. So we can already see that our nitrogens are balanced because they are the same. Our hydrogens are balanced, but our oxygens are not balanced. So what do you think we're going to do to balance the oxygens? Literally, we're just going to add a 2 here because now we have four oxygen atoms. And now it is balanced. So that's basically how you do it. You count the amount of atoms, then you see where do you go around doing it. Okay, so the next reaction that we'll be balancing is metal plus water, which makes metal hydroxide plus hydrogen, and we'll be doing the lithium reaction. Okay, so here I've got the equation typed up. So first of all, we have Li, H, and O atoms on both sides. So I'm literally just going to write Li, H, O, like this. And we have one lithium on the left side, two hydrogens, and then one oxygen. Okay, and then on this side, we have one lithium, we've got three hydrogens, and then we've got one oxygen. So we can immediately see that the hydrogens are not balanced, okay? So what you could do, there is two ways you can go around this equation. What you could do, and which I think is the more simpler way, is just by adding a half here. Okay, because if I add a half here, now half times 2 is 1. So now you have 2, okay? If we basically try and bring this number to 4, okay, if I just put a 2 here, okay, two hydrogens, that's 4, then now we can easily get this one up, okay? So if I just get this to 2 as well, now we have 4 hydrogens, okay? But now we've got a slight problem. Okay, now the lithiums and the oxygens are not balanced. So now we have 2 lithiums and we have 2 oxygens. And hang on, no, our oxygens are balanced now because I put a 2 here. So now we've got 2 oxygens here and 2 oxygens there. But now our lithium, we've got 2 on this side and we've got 1 on this side. So literally, if I just add a 2, that's balanced, okay? Right, so the next question, you can pause and try and do it yourself, and then we'll go over it. So, first of all, we're going to count the atoms. So R, B, H, and O. Oops, that looks like a really disgusting O anyway. We're just going to put O here, and I'm just going to basically do it like this. So we have one rubidium on this side, on the left side. Then we have 2 hydrogens and 1 oxygen. Then on the right side, we have 1 rubidium, 1 oxygen, and 3 hydrogens. Okay, so with this, I think it's just easier if you bring this number to 4, then you can match it up and bring that number to 4. Or you can literally just add a half here, because when you add a half, okay, now we have a half times 2 is 1, now we have 2 on both sides. As you can see, that kind of simplifies it when you add a half here, okay, because you've literally immediately balanced the equation. Or the next way, the longer way, which you can do, is we're just going to have to balance it. So we've got 2 hydrogens here, we've got 3 hydrogens here. The rubidiums are balanced. So what you could do is you could just bring the number to 4. Okay, so if I just add a 2 here, then now we have 2 hydrogens, 4 hydrogens. Okay, but now I've got 2 rubidiums and I've also got 2 oxygens. Okay, so now everything's not balanced. So now if I just add a 2 here, the rubidium's balanced. Now the oxygen is still not balanced and neither is the water. So literally if I just put a 2 here, we've got 4 hydrogens now and 2 oxygens. Okay, let's do another example. You can try and do this yourself. You can pause the video. Okay, so let's do this one. Here we have chlorine reacting with potassium bromine to produce potassium chloride and bromine. So this is a displacement reaction. So if I just count our atoms, KL, K, Br, Cl, K, and Br. Let's just draw a table. Okay, so on the left side we have two chlorines, one K and one Br. Then on this side we have one K, one Cl, and two Br. So as you can see, we've got two things. We've got the Cl that's not balanced, and we've got the Br that's also not balanced. Okay, so what we're gonna do is we've got two bromines here. If I just add a 2 here, now the bromines are balanced, but now I've got two Ks, right? So if I just put another 2 here, now I've got two Ks and I've also got two Cls. That's literally how you do it, guys. Drawing the table and doing it like that is the best example. Okay, let's go over another example. Okay, I've already got this one done. So literally you're going to do the same thing. You're going to count the atoms, aluminium, iron, and oxygen. You're just going to count them. Originally, we have one aluminium, we have two Fe's, which is iron, we have three oxygens. Okay, and then on this side, we originally have one iron, two aluminiums, and three oxygens. So in the beginning, we have the aluminiums and ions in balance. So what I've basically done, I've started by putting a 2 here to balance the aluminiums, okay? But now we've got one Fe and two Fe, literally just put another 2. So it's really not that complicated. Okay, so let's try and do another one. You can pause the video and you can do it yourself. Okay, so with this one, again, it's actually very easy once you count the atoms. So I've done my C's, done my H's, and done my oxygens. And we can first figure out that we've got one carbon, okay? Then we've got six hydrogens, then one oxygen. Then we have one carbon on this side. We originally have two and one oxygen. So literally, if you need to think about your common multiples here. If you just put a stick of 3 there, now you've got six hydrogens, and now it is balanced. So I hope you guys found this video helpful. Make sure to subscribe, like, share for more GCSE science and potentially maths videos coming up soon. Guys, so